All right, let's take a look at adding and subtracting rational expressions. But before we look at some of those examples, let's take a journey back to elementary school, primary school, whatever you want to call it, and I want to look at adding fractions. So your teacher in elementary school might have said to you, how do I add a third plus a quarter? And if you think about what a third looks like, a third is just a third of a pie, right? So this is a third of a pie. And a quarter is a quarter of a pie. So here we go, I have a quarter of a pie. And I want to know, if I take these two together, how much of my pie would be filled in. And you can kind of estimate it. Here's a third, and then here's my quarter. I wonder how much that is, kind of close to a half. So what your teacher probably talked about was that you have to kind of recut this pie so that way they're in similar pieces, so you can know exactly how much was filled in. So we would find a common denominator by multiplying this fraction by this denominator and this fraction by this denominator. And essentially what we will have done is created a situation where now I'm talking about both of these sections in terms of 12ths. So how many 12ths will I have added together? I don't know, 4 plus 3 gives me 7 12ths, which is kind of close to a half. My picture is not perfect. Maybe I should have gone a little bit over, right? But this is really what the idea of adding or subtracting fractions is. And now we're going to translate this concept to an expressional denominator. So here's our first example of an expressional denominator. Something like 3 over x minus 2 plus, let's keep it with the 4, right? Kind of relating it back to the other fraction. 4 over, how about x plus 5? So not too complicated. It's a similar idea. I want to have a common denominator. And since these numbers, because they are numbers, right? The expressions are representing a value. Since these expressions really don't have any common factors, what I'm going to do is I'm going to multiply this expression by an x plus 5 on top and bottom. And I'm going to multiply this expression by an x minus 2 on top and bottom. Now, why am I allowed to do that? Well, this value is really just 1, as is this one. So I'm not changing my fractions at all, similarly to here where I wasn't changing the fractions, I was just splitting it up into different parts. That's what's happening here. So now I'm going to take this 3 and I'm going to distribute it to those two values, and I'm going to take the 4 and I'm going to distribute it to those. Let's see what we get here. We get 3x plus 15 plus a 4x minus 8. And that's going to be all over my common denominator. I'm not going to write that out quite yet. All over my common denominator. And then I have, let's see, 3x plus 4x gives me 7x's. And then 15 minus 8 gives me another 7. And then let's actually put in our common denominator now. It's a x plus 5 and an x minus 2. X plus 5 and an x minus 2. And you're welcome to leave it, the denominator, in any form you would like. You can leave it in factored form, or if you prefer, you could distribute this out and get it into standard form. But that's really a personal preference. Sort of the requirements is that you simplify the numerator to its lowest term. So you really want to kind of combine like terms in that numerator. But the denominator can be left in any form you would like. So that's really the idea of adding and subtracting rational expressions. In the next video, I'm going to show you something a little bit more complicated.